Problem number one. You have a three-man slingshot. I don't know if you've ever seen one of those. Two people hold each end. Someone else holds the balloon and they launch it. So you can say your initial position when the slingshot is stretched is x equals 0. And when you let the slingshot go, the final position before it leaves the slingshot is x final, which is equal to 3.4. So you can say that your delta x is equal to 3.4. That's simply x final minus x initial. Your velocity initial before you let the balloon go, of course, is 0. Your final velocity when you let the slingshot go is 19.2 meters per second. Big question is, what is your acceleration? What is the acceleration of this balloon? I'm going to shrink this, move this out of the way. It's our drawing. You should always draw a picture. Always draw a picture. Let's rewrite everything. Your velocity initial, of course, before you let the balloon go is 0. Your final velocity when the balloon leaves the slingshot is 19.2 meters per second. The initial position of the balloon is 0. The final position of the balloon is 3.4 meters. And of course, your delta F would be 3.4 meters also. And they want to know the acceleration. After going through the equations on page 88, I have chosen velocity final squared is equal to velocity initial squared plus 2a delta x as the appropriate equation. We know velocity final, we know velocity initial, we know delta x, and we can rearrange the equation to solve for a. Now, you should have all these. Now we just plug and chug. Your velocity final is 19.2 meters per second. And I take the whole thing and I square it. Minus 0 meters per second. Take the whole thing and square it. Most of the time I won't even write that 0 meters per second. There is no reason to. I'm just helping you along to show you that, you got 0 there. Then we have divided by 2 times 3.4 meters. And you land up with 54.2 meters per second squared. Now if you look at the units, meters per second squared, I should say meters squared, seconds squared on top. After you square everything, meters on the bottom, the square cancels. So this is what you have, 54.2 meters per second squared. Let's look at problem number 2. We have a TF North football player, and we have our big, strong TF South football player. The TF North football player is running to the right. His initial position is equal to 0, and he makes it approximately 1.2 meters before he's stopped by the TF South football player. His initial velocity he was running at 7.2 meters per second. And when he was stopped, of course, his final velocity was 0 meters per second. The question, what was the acceleration on the TF North football player? Now looking at the equations on page 88, I determined that I should use the very last equation. I have rearranged it as such, which I've done for you already. Now we just plug and chug. Of course, our velocity final is 0, so we don't even have to write that, but we do have to write the negative sign. Now what you really have to watch here is I put this squared and I leave this negative sign here. Divided by 2 times the change in x, of course, is 1.2 meters, is equal to 21.6 meters per second squared. Problem number 3. We have a Nerf gun. The Nerf gun's barrel is 0.76 meters long, which means our initial position is equal to, of course, 0, and our final position of the bullet as it travels down the barrel is 0.76 meters. Now again, this number here, that is delta x change. What was our initial velocity of a Nerf gun bullet? Of course, when it's still in the gun, before you pull the trigger, its initial velocity is 0. And when it leaves the barrel, we don't know what its velocity is. Can we determine it? Of course, it gives you the acceleration is 16 meters per second squared. Now, knowing all these values, I chose the problem on page 88. The last formula seems to be the easiest. Don't forget what we have is velocity squared. We don't want that. We just want plain old velocity final. So let's take the square root of both sides. You have velocity final is equal to square root of that. Velocity initial is 0, so let's just get rid of it now so we don't have to put the 0 in there. And we have 2 times the acceleration, which is 16 meters per second squared, times delta x, which is 0.76 meters. Always make sure your square root sign goes all the way across. Now look, I'm bracketing this so when you put it in your calculator, you get the correct answer. And you should have an answer of 4.93 meters per second.